Coming up, we have an exciting keynote, an additional keynote here called Technical and Extra Technical Touchstones of Trust in AI. Coming to the stage is Cynthia Dwork, Professor of Computer Science at Harvard University. Cynthia Dwork is the Gordon McKay Professor of Computer Science at Harvard University, John A. Paulson School of Engineering and Applied Sciences, and affiliate faculty at Harvard Law School. She uses theoretical computer science to place societal problems on a firm mathematical foundation. Dwork joined Harvard after more than 30 years in industrial research at IBM and Microsoft. Her recent awards and honors include the 2020 ACM, SIGACT, and IEEE TCMF Knuth Prize, the 2020 IEEE Hamming Medal, and the 2017, I'm going to mispronounce this, Gödel Prize? Close enough? Mm-hmm. Without further ado, Cynthia Dwork.
Thank you. Okay. Good afternoon, and thank you for inviting me here. When I wanted to give a technical talk, because that's what I do. I'm a technical person. And when I sent my title and abstract to Rick, he was politely aghast and asked me to change what I was going to say completely. And so I've decided to talk to you about some thoughts from a paper I wrote with Harvard University professor and former dean of Harvard Law School, Martha Minow. And I'll have like 2 short forays into technical matter because, as I said, that's what I do. So we were interested in trust and mistrust. And you've all seen polls like this, Mitre-Harris poll, showing that most Americans want artificial intelligence to be regulated. And in fact, 82% of American voters don't trust AI companies to self-regulate. So just to ground this a little bit, what is trust? Trust is it's a belief in the reliability or the truthfulness or the accuracy of a person or a thing. And trust is associated with comfort, security, and confidence. And the absence of trust then implies doubt about the reliability or the truthfulness or the accuracy of a person or thing. And this generates anxieties, it alters people's behaviors, and it undermines the cooperation that's needed for private and public action. Now, I'm not sure that you care about who trusts AI, but here's why, some of the reasons why we believe that you should care. Regulation, watchdog and lobbying group pressures, lawsuits, the possibility of taxes to govern behavior. So I can't speak to any of this. And the fact that I think that you might have to, that these would be reasons to care is completely irrelevant. But the fact that Professor Minow thinks these are reasons to care, given her expertise, is actually significant. So I'm going to talk quite a bit about some sources of mistrust in AI. The data can be faulty, they can be biased, and by biased, that can mean various things not representative of the population, or differentially expressive features or skewed outcome proxies. And let me just give you, a few examples. You've probably all heard of the gender shades, and that explains the not representative reference. The Eubanks reference, the differentially expressive features, is a little bit different. You can have text that is exactly the same for someone from an impoverished household and from a wealthy household. And this arises, for example, in the context of the Allegheny County tool that is used to help screen possible child abuse cases into the system or out of the system. So they get a call, they need to make an evaluation, should they screen it in or screen it out? And one of the things that they do is they look at all of the Pennsylvania information that they have, all of the information they have through the government. Now, take something like substance abuse treatment programs. A poor family, if they have been through substance abuse treatment, it's probably been through the state and there will be a record. In a wealthy family, somebody who has been through substance abuse treatment will probably have gone privately, and there won't be a record available at this time. So the absence of a record of substance abuse treatment means very different things in these two cases, and that's what I mean by differentially expressive features. For skewed outcome proxies, you've probably all heard about, say, using rearrest as a proxy for committing a new crime, and that is, of course, depends on where the arresting is happening. Okay, now, sometimes, not only, we gave an example where the data were incomplete, sometimes they can be too complete. So I'm going to talk about two instances here, two papers. Both are about privacy considerations. The first in a setting that doesn't have privacy promises, but has some privacy safeguards of sorts. And the second is one that sort of even has privacy promises. So court records provide an essential window into the function of one of the three pillars of government, specifically the courts. And yet, courts, in the words of the authors, Conley et al., written at the bottom, courts are a stage where many of life's dramas are performed, where people may be shamed, vindicated, compensated, punished, judged, or exposed. And there is a privacy issue that arises here as a result. And so you might think that when the court was transitioning to records that were available if you went to the courthouse, to records that are searchable from the web, that it really shouldn't make much of a difference. I mean, the stuff was public in the first place anyway. But there is a profound difference. And in fact, courts did have some ways of having some privacy controls. The state legislature has power to make exceptions to the right of public access. There's individual power to challenge the disclosure of certain court records, and so on and so forth. But that was getting lost. And the authors claim more than 10 years ago was that the courts have an obligation to rewrite the rules governing the creation of and access to public court records in light of the substantive changes that online access augurs. And kind of the point of the next example is plus ça change, plus c'est la même chose. So now I get to do my first technical foray. Differential privacy is a definition of privacy that is tailored to the statistical analysis of large data sets. And in English, a differential privacy guarantee says roughly that if I'm unlikely to be harmed by an analysis when my data are not included, then I am unlikely to be harmed when my data are included. And differential privacy is the property of an algorithm, and it has no connection to what an adversary or an analyst happens to know. Now, the industry practice when trying to build differentially private models for let's say some particular corpus, hospital data or something like that, is to first train models on public web scraped data without privacy, no privacy guarantees, and after all, it's public data, just as the court records might now be public, to learn generic features, and then fine-tune the model in a differentially private way using the confidential data like the hospital data. And the issue here is that the public information can also be sensitive. Some information about you might have been posted because you filled in some form somewhere, and those guys eventually decided to post all of their records, and now stuff about you is there, and you didn't even know about it. And more generally, the public and the confidential data can intersect. And so now, what is a promise that, oh, we trained this in a privacy-preserving fashion? Yes, in some sense, any sort of guilt about what becomes known about you has nothing to do with the second phase, the fine-tuning, but it did show up in the first phase. And so in some sense, we're back to maybe the recommendations of Conley et al. From the previous paper, which is, do we need to rewrite the rules of collection? Okay. Great. And another example, of course, of source of mistrust, think about actors, artists, and so on. Here's from The Atlantic earlier this month, talking about concerns and saying that it's a tacit response to hundreds of pages of litigation and countless articles accusing tech firms of stealing artists' work to train their AI software, and so on. Okay. So other sources of mistrust include errors in what is being produced. And this is an article from August in the Boston Globe, where asked to generate clinical vignettes, which are the kinds of things that are used for training medical students, of a sarcoidosis patient, the algorithm described a black woman 98% of the time. Now, it is true that sarcoidosis has higher incidence in the black population than in other populations, but it's nothing like 98% of the cases. And quite astonishingly to me, students are being trained on the vignettes produced by the LLMs. So when people say, oh, but it's okay, people will take the information as advice, but they'll also bring their own knowledge to bear. Their own knowledge is this. So the quote is, how are they going to second guess an LLM if they use an LLM to train their own brains? And that's a quote from a health policy researcher at Harvard Medical School, Ativ Mehrotra. Now, this is, I thought, just my personal concern, but I am going to take you through this next one, and I'll talk a little bit, if I have time, about why I think it's relevant, even though this isn't a very common concern. So this is my second technical foray, and it's my reason for distrust and why I think that others shouldn't trust. So an individual probability, what is that? Well, we have risk predictors, and risk predictors, or scoring functions, assign numbers to people, typically numbers between 0 and 1, and they are viewed often or interpreted often as probabilities. So for example, what is the probability that it will rain tomorrow? So there's probability, 30% chance of rain, and tomorrow it's an individual instance. It's not like on average, on the 19th day of October, what fraction of days does it rain? No, we're asking about tomorrow. Or what is the probability that this particular person, X, will repay the loan? Or what is the probability that this tumor will metastasize under a given course of treatment? So very specific. And what is the probability that individual Y will commit a violent crime in the next 2 years? So you've all probably seen these sorts of things, and people will talk about likelihood. How likely is it that Y will commit a crime? But the question sort of struggles even to make sense mathematically. What is the meaning of the probability of a non-repeatable event? You can't give the loan to X, see whether X repays, rewind history, do the experiment again, rewind history, do the experiment again, and get some sort of frequentist notion of probability. So this turns out to be a very deep philosophical problem in the philosophy of probability. So why is this a bother? Well, the algorithms are producing these numbers, which are supposed to be individual probabilities, and since we don't know the meaning of the term, it's not clear how should we evaluate a predictor? How do we evaluate a forecaster? So there's a long literature on this kind of thing, starting with Philip David's work in 1982 or earlier. That's the earliest paper I've read, which sort of deals with the online case, but a lot of times in machine learning and AI, we're dealing with the batch case where you train on a bunch of data and make predictions about new instances. But in any case, since we don't know what the meaning of a probability is, it's not clear how we're supposed to evaluate a predictor. And that's kind of what that whole line of research for the last 40 years has been looking into. And we want to evaluate it, and we want to improve it. And this is a very active sub-area in algorithmic fairness research. And it's really exciting, and I'm thrilled with some of the things that I'm seeing. And very recently, people have started extending these solution concepts that have been developed for individual probabilities to language models. So getting close. OK, now, since I have a few minutes, and I don't have that much more that I wanted to tell you, I was thinking, when I was preparing for this talk, about why did this come up so much now in the context of like ordinary predictions that are done in everyday life? Why doesn't it come up when people talk about, say, standard regression? And is it just me? So first of all, it's not just me. I mentioned that Philip David has been working on this since 1982. In 2014, he wrote a paper on the meaning of individual risk. And he was asking exactly the same kinds of questions that we've been trying to address in the algorithmic fairness literature. If now just conjecturing, I think that what's going on is a combination of two things. The predictions are being used for very high stakes decision making, but this was always true. In medical, which treatment plan do you want? That's very high stakes. So that was also true. But I think now perhaps there's this element of the person who is subject to the prediction has no agency in terms of what to do with the prediction. In other words, you might be told by your doctor, if you do this, here's your chance of 5-year survival. If you do that, here's what we think your chance of 5-year survival is. And then you have a conversation, and I'm not saying that doctors understand probability, but they do sort of know that they're talking about similar patients or patients who share certain features, and you have some agency in deciding what to do. Ultimately, it's your choice. And I think now perhaps the new ingredient is a complete lack of agency. I'm not sure. I'm throwing this out here for people who are in fields that are more closely aligned with the question, might be able to make some progress on. OK. One other source of mistrust is a divergence of interest. So why do we trust people? Often we trust them because, I trust you because your interests encapsulate mine to some extent. In particular, because you want our relationship to continue. And if you look at, say, let's go. I want to go to, sorry. Come on, there. No, my mistake. OK, so if you consider how do we deal with trust in other situations, like hospitals and schools, this depends on being able to assess the reliability of the institution and assess how it behaves when in response to errors, which are inevitable. So what's the redress, and how do they respond, and how do they change? And if the opportunity to do this in AI is somewhat lacking, and there are no governing norms and practices. OK. So steps towards trust. One is regulation and collection and regulation of the use of data. Another is recourse for errors and bias commensurate with the risks. So not trivial recourse, but if you've been harmed, getting something back that actually is commensurate with what you've lost. And these are non-technical, perhaps. A more technical are these methods for evaluating and improving the predictors or whatever your algorithms are doing. And as I said, this is a really exciting area of research. And it is a way of stepping toward trust, especially because there's a big role for public input in the evaluation. And then the improving, given the bad evaluation, is the technical part. So my sort of favorite is, I don't know what's, okay, what I'm going to call responsible scaling. So who knows what ship this is? Yes? It is the Titanic. And what did the Titanic not have enough of? Lifeboats. You can't run a steamship service or whatever without having enough lifeboats anymore. It's not legal. And if we look at the kinds of harms that can be done, for example, in social media, when the companies say, well, it would be too expensive, it would require too many resources to control that, I don't understand. I don't know whether it means we would be wiped out. And if it's true that to make it safe, it would wipe out the whole business, I don't know whether that's right or wrong, but it's something that has to be looked at. And if it's just, well, we can't make as much money, then again, that's something that needs to be looked at and considered. But scaling should be responsible. Okay, that's it. Yes?
We will take questions.
A wonderful presentation, Cynthia, enlightening. So I want to add onto your probabilities slide one more thing that I don't like, and I would like to know your opinion. It's not only that we are predicting things that will never happen again, but also we are using data from other people to predict, for example, me or you. And I don't think that's very scientific either. So what do you think about that?
I think you have a point. I think that there could be things that we can learn from other people that would be relevant to us. Clearly, if we learn something causal, this gene causes that, or this gene is associated with, that is relevant.
I'm talking about behavior, for example, returning alone.
Right.
Not about medicine.
Right.
About genetics, I agree.
Right.
But non-genetic thing, like I will return the loan.
Yeah.
And this is my first loan.
Right, right. It's a reasonable objection. And it kind of gets to the heart of, we are no longer talking about me. The individual probability, it's supposed to be about my pain. Even if we knew what an individual probability was, it should be about me, and it shouldn't be about people who quote unquote look similar. I don't even know what the similarity metric should be. Who is similar to whom? How do you decide what is the right metric for similarity? I think it's a really important question. I've worked on it in other contexts, but it's not at all clear. Yeah, good. Any other questions? Yeah.
Hi, I like that you mentioned evaluation. I think that's not been mentioned enough here about responsible AI, which is what I call the last mile of AI safety, right? You can do all you want, you can be responsible inside your corporation, but when you send out this model into the world, who's checking?
Right.
Right? Who's checking that your autonomous vehicle has correct pedestrian detectors today? Right? That's a really big unsolved problem, right? And the way I like to say is, we need to figure out how dummies can evaluate experts.
This is right.
Right? Because we're eventually going to develop such intelligent systems that we're not going to be smart enough to evaluate them.
Although I have to say that if there were experts who could evaluate experts, I'm okay with that. I'm okay with delegating evaluation to somebody who knows more than I do about a subject. I do it all the time. So I believe in expertise, But an evaluation method is important, and evaluation criteria are important, and just the raw counting is typically not enough. Yeah. Yes.
So, I asked this question in the workshop yesterday, and I'm still curious about it. I had a good answer from a lawyer yesterday. You talked about recourse for errors and commensurate with the risks.
Mm-hmm.
Do you believe there's space for incentives to do it right?
Yes, and I think that taxes are one of them.
Oh,
that was on my
U.S. incentives like negative. Okay.
Mm-hmm.
Okay.
Right.
Or
Or tax incentives for doing it right. Yes.
Okay. Okay. Okay, that's fair. We had a lawyer saying that you can't reward people for doing what they're supposed to do, and
I think we do it all the time.
If I represented you correct. Thank you.
Yeah. I'll take it back. Yes?
Hi. So you talked about the need for regulating the acquisition and the use of data, and I'm wondering, it feels like it has to be some sort of government regulation, but it seems very hard to define at which level should government restrict it. With the Titanic example, I can sort of understand the immediately, okay, we need more lifeboats. That's immediate. With data, I have trouble understanding how we would do that. Do you have any ideas?
No. No, I don't think about how regulation should work typically. It's not my forte. I'm sorry.
Okay. And how do we who should we trust with that decision then?
I think my co-author, Martha Minow, would be the right kind of person to trust with that.
Sounds good. Thank you.
Yeah. Yes.
We have time for one more question.
The recommendation to
Wait.
roll it with
The virtual listeners will come after me.
Sorry. Thank you for your presentation. I think it's really salient. My question to you is, as you are suggesting and others are suggesting, regulation, that would be through governments. And we're having trouble even maintaining a functional government these days. How do we make these regulations, how do we put them in place before AI completely overwhelms everyone?
That's a very legitimate concern, and it's a big concern of mine, and I'm sorry, I wish I had an answer, but I don't.
It is a question that is out there that I think all of us will be challenged to answer in the coming years.
Absolutely.
But thank you.
Yeah. Okay. Hi. Oh.
Can we give a round of applause for Cynthia Dwork?